All right, this is the key to test one. Okay, so in the first part, it's multiple choice, and there's 6 problems, 5 points each, and the first question has to do with the equation of a circle. So you're given this equation of a circle, and you're asked to find which of the following is the center and the radius. Well, remember, the equation of a circle, this is in standard form, so let's talk about standard form. So the standard form of the equation of a circle looks like this. It's x minus h squared plus y minus k squared equals r squared. So that's the standard form of the equation of a circle. A couple of things you need to notice is that in this form, it's written as x minus h and then y minus k. And then over here, this is r squared. It's not r, it's r squared. And so in the standard form, the center is hk and the radius is r. The length of the radius is r. And so in this equation you're given here, if you write it just like it looks like this, you would have this. You would have x minus 3 squared plus y minus a negative 4 squared. Because remember, y minus a negative 4, y subtract a negative 4, you can always change subtraction to addition. And so that becomes y plus the opposite of a negative 4. So that's a positive 4. So y subtract a negative 4 means the same thing as y plus 4. And then 16 I can write as 4 squared. And so h here is 3 and k here is negative 4 and your radius is r. So the center in number 1 is 3 negative 4 and the radius, the length of the radius is 4. And so the choice that goes with number 1, the answer number 1 is B. All right, so B. All right. Number 2, you're told that a quadratic equation has a discriminant of 81. And then which of the following is correct regarding the number of solutions and the type of solutions for this equation? Okay, so you got to remember that in the quadratic formula, and so remember this is a quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. The discriminant is the radicand of this quadratic formula. So your discriminant, the discriminant is b squared minus 4ac. And you're told that the discriminant is 81. Well, if you were to actually substitute this value into the discriminant, you would at some point in this quadratic equation, you would have the square root of 81, which is 9. So notice that 81 is a perfect square. So that's a perfect square. And so when I take the square root of 81, I get 9, and 9 is a rational number. So notice I would get the opposite of b plus or minus 9 divided by 2a, whatever a, b, and c are, that's what I would get. So notice a rational number plus or minus a rational number divided by a rational number is a rational number. Okay, so when you have a perfect square, remember when you have a perfect square, you're going to get a rational solution. You would get rational solutions or roots. And there would be 2 of them because plus or minus, you would have negative b plus 9 divided by 2a, and then negative b subtract 9 divided by 2a. All right, so there would be 2 rational solutions. So the answer choice here is C. All right, number 3, you're asked this time to determine the distance or define the distance between these 2 points. And so we're going to use the distance formula. And so the distance formula is the square root of x2 minus x1 squared. So basically you're going to subtract the x coordinates from each other and you're going to square that, plus, and then you're going to subtract the y coordinates from each other and you're going to square that. It does not matter in the order in which you subtract these coordinates, because you'll be squaring, and so if you say x2 minus x1 and that's negative, when you square a negative you get a positive. If you do the other way around, you get a positive squared is still a positive. So whatever you choose here whatever you choose here, it does not matter in the order in which you do it. You would get the same value for this expression squared. Alright, so it's a good idea when substituting values into this expression to actually label your coordinates. So let's call this the first point. So this will be x sub 1, y sub 1, and this will be the second point, x sub 2, y sub 2. And then we can just substitute. So we get d equals, the distance equals. Alright, so I'm going to start with 5. So I'm going to say 5 subtract a negative 3. So I'm subtracting the x coordinates from each other. And whatever that is, I'm going to square it. Plus, and then we subtract the y coordinates from each other. So 6 subtract 2. And whatever that expression is, I'm going to square it. Well, 5 subtract 3, remember that's 5 plus 3. So I'm going to get 8 squared. So that becomes 8 squared plus, and this 6 subtract 2 is 4, so it becomes 4 squared. And so 8 squared means 8 times 8, which is 64. So the square root is 64 plus 4 squared, 16. So I get the square root of 64 plus 16 is the square root of 80. Now notice the square root of 80 is not here. So you're going to have to simplify this to see which of these expressions is equivalent to the square root of 80. So remember, we're going to use a perfect square. What's the largest perfect square? That's going to go into 80. It's always easier to use the largest. So the largest perfect square that goes into 80 is 16. So I get the square root of 80 is the square root of 16 times 5. So the square root of 16 times the square root of 5. And the square root of 16 is 4. So I get 4 square root of 5. So the answer choice to number 3 is C. I get C there. All right, number 4. Okay, number 4, this time you're given a circle, the graph of a circle, and you're asked to determine the equation of that circle. Well, to determine the equation of a circle, we're going to use the same standard form that we used in number 1. So the standard form of a circle. So remember, the standard form of a circle is x minus h squared plus y minus k squared equals r squared. So that's the standard form of a circle. So in this case, you can look at the center and determine the coordinates. So let's assume that all of these tick points represents 1 unit. So this is -1, this is -2, so my x-coordinate of the center is -2, and then we go up 1, and so the y-coordinate is a +1. So that's the center of the circle. And so the other thing I need to know is the radius. So remember, to find the equation of a circle, you need to know the center and the length of the radius. So the radius, remember, the radius is the distance or the length from the center to a point on the circle. Let me go do it this way. So there are an infinite number of radii. All these are radii. All right, so I'm going to kind of darken these for a reason. And so there's an infinite number of radii. Notice that all these radii have the same length. So in this case, it's easier to determine the center by using one of these 4 radii. So if I go from the center straight down, notice that's 1, 2, 3 units. If I go to the right, 1, 2, 3 units. I go up, 1, 2, 3 units, and so on. So all of these radii have length 3. So the radius is 3 units. And so when I substitute these values into this standard form of the equation of a circle, remember, this is h, this is k, I'm going to get this. I'm going to get x minus h is a -2 squared, plus y minus k is 1 squared, equals r, which is 3, and that's being squared. And so you're going to rewrite x subtract a -2 as x plus 2 squared, and then that's going to be y minus 1 squared, equals, and then 3 squared is 9. And so that is going to be your answer. And so the one that works would be letter D. So the answer to number 4 is D. Okay, number 5. You're given the equation of a circle, and you're asked to find the domain and range of this circle. And so remember, the domain of a relation is the set of all x coordinates. And the range is the set of all y coordinates. So basically, if you look at the circle, there are an infinite number of points on the circle. So there's an infinite number of points, and what you got to find is what are the x coordinates of each point, what's the set of all these, and then what's the set of all these y coordinates. The best way to determine the domain and range given a graph is to actually go from left to right to determine the domain, because if you think of the domain, think of the x coordinates, so think of the x-axis. So you're going from left to right. And for the range, since you're dealing with the y coordinates, think y-axis, so you're going from bottom up. Now you go from left to right because when writing the domain and range in interval notation, you always go from smallest to largest. So from smallest to largest. Okay, so for the domain, let's talk about the domain. So that's the x coordinates. So when I go from left to right, my first point I get to is this right here. And so notice that the coordinates of this point, in terms of the x coordinate, is negative, what's that, 6, 4, 5, 6, so negative 6. So I'm going from negative 6, if I kind of do this right here, so I'm going from negative 6, so all the way to, so negative 6, and all these are the values of all these points. So let's say this is negative 3, so this point right here has coordinate negative 4 rather. This point right here, if I go right in the middle, that's negative 2.5, so this point has x coordinate 2.5. So you're trying to find all these x coordinates here. And so when I go from left to right, I start with negative 6, and I'm going to end up going, and I stop here, which has x coordinate of 8. So this has x coordinate 8. So my domain is going to be any real number between negative 6 and 8. So for example, if x is 4.25, which is about here, I get this point and I get this point. And so if you look at these points, those are the x values, 4.25, 4.25. So my domain will be any, so that's your domain here. So domain would be any real number from negative 6 to 8. Now notice it's bracketed because when you look at the graph, those are solutions. So every point on the graph is a solution. And so when you write the interval notation, you're going to use brackets because those are solutions. So those are points on the graph. If there were not points on the graph, and you're going to see this later on, but if they're not points on the graph, you use parentheses. So right off the bat, you could eliminate C and D, because C and D has parentheses here. And so when writing domain and range, you're going to use brackets unless that point is not in the circle. And so we haven't talked about that yet. The range is a set of y values and go from smallest to largest. So let's talk about the y-axis in this case. So the lowest point on the graph is here, and so that is negative 10. And the largest point on the highest point on the graph is this, and so that has y value 4. So every real number between negative 10 and 4 is going to be a value of the y coordinate of these points. So this is your range here. So my range is going to be from bracket negative 10 all the way to 4 with a bracket. And so the only answer choice here is going to be B. So that's your answer, B. So the domain is negative 6 to 8, and the range, so negative 6 to 8, and the range is from negative 10 to 4. So I'm sorry, B. All right, number 6. You're given a graph, and you're asked to find the intercepts, meaning the x-intercepts and the y-intercepts. Remember, the x-intercept is where the graph touches or crosses the x-axis. And the y-intercept is where the graph touches or crosses the y-axis. And to look at this graph, there are two places for your intercepts. So in this case, this is where the graph crosses the x-axis, so that's going to be an x-intercept. So this is your x-intercept here. And then here, this is the point where the graph crosses the y-axis, so that's your y-intercept. And so notice that the answers are written as ordered pairs, so you got to make sure you write the correct ordered pair. So to get to this x-intercept here, remember you're going to store the origin, and you go to the left 2 units. So that means that my x-coordinate is -2. Since I'm not going up or down, I'm staying there, my y-coordinate is 0. Over here, I store the origin, I'm going straight up. So since I did not go left or right, that means that your x-coordinate is 0, and your y-coordinate is 8. So the only choice here for -2, 0, and 0, 8 is going to be D. So D. So the answer to number 6 is D. All right, now the rest of the problems, part 2, is where you actually have to do some work. So you have to show some work. So number 1, you're given these two complex numbers, and you want to simplify that. So you're going to perform the indicated operation, you're going to simplify. So you're subtracting these two complex numbers, but notice that this complex number is being multiplied by 2 or -2, depending on how you write it. And so what I would do here is think of this as adding a -2, so you're going to be distributing a -2 within that parentheses. So I get 3 subtract 4i, a -2 times 4 is a -8, and a -2 times a positive I is a -2i. Okay, now we're going to combine like terms. So when I combine like terms, when I add the real part together, so 3 and -8 is a -5, and then a -4i and a -2i, when I combine those two terms, they're like terms. So when I combine those imaginary terms, I get a -6i. So that's answer number 1. Number 2, though, when you look at what you're doing to those two complex numbers, you're actually multiplying them. So notice that you have two terms in here, two terms in here. So just like you did when you multiply two binomials, you use the FOIL method, you do the same thing here. And so when I FOIL this, remember, F stands for first, and you multiply the first terms together. So the first term in this binomial is 5, or in this parentheses is 5, and the first term here is 2. So 5 times 2 is 10. The outer terms on the outside, 5 times a -3i is a -15i. The inside terms, 2i times 2 is a positive 4i. And then the last terms of each parentheses, so a positive 2i times a -3i is a -6i squared. Now, remember, you have to use the fact that I squared equals a -1. So I'm going to get 10. Now I'm going to go ahead and combine these two terms. A -15i and a positive 4i is a -11i. And then this right here becomes -6, or subtract 6 times a -1, because remember, I squared is a -1. Rewriting this, I get 10 subtract 11i, a -6 times a -1 is a positive 6. And then remember, you want to write this in standard form. So standard form is a plus bi. So I forgot to mention that here. So again, standard form is a plus bi. So you want to put the real part first, so -5, and the imaginary term second, so -6i. So when I rewrite this, first of all, I'm going to combine like terms. I get 10 plus 6 is 16 minus 11i, and that is standard form. So I'm just put that here, 16 minus 11i. Over here, you're dividing these complex numbers. So remember, when you divide complex numbers, you don't want an imaginary term in the denominator. And so you're going to multiply the numerator and the denominator by the conjugate of the denominator. And so the conjugate of 6 minus 5i is 6 plus 5i. And so when you do that, what's going to happen is that the denominator of your answer is going to be a real number. It will not be a complex number that has an imaginary part or imaginary term. So I'm going to say 6 plus 5i divided by 6 plus 5i. So that's your next step. Now I'm going to rewrite this. See how you're multiplying two numerators together? So I'm going to write this as one fraction. So it'll look like this. The numerator will be 4i times, in parentheses, 6 plus 5i. Because remember, both terms here have to be multiplied by 4i. And then here I'm going to write this as 2 parentheses, 6 minus 5i times 6 plus 5i. All right, now the next part is to get rid of the parentheses in the numerator. I'm going to use a distributive property. So 4i times 6 is 24i, and then 4i times 5i is a positive 20i squared. In the denominator, I'm going to use a FOIL method here because you have these two binomials. And so 6 times 6 is 36. That's your first. Your outer, 6 times 5i is 30i. Your inner, a negative 5i times 6 is a negative 30i. And so you may recall at this point that when you multiply two binomials that are conjugates of each other, the outer and the inner add up to 0. And so the last term now, a negative 5i times a positive 5i is a negative 5i squared. Okay, so again, we're going to remember the fact that I squared is a negative 1. So in place of I squared, so I have an I squared here, and I have an I squared here, I'm going to write negative 1. So what I get is this. In my numerator, I get 24i plus 20 times, remember I squared is a negative 1. My denominator, I'm going to get 36, subtract 5 times I squared is a negative 1. Okay, now my numerator becomes 24i, a positive 20 times a negative 1 is a negative 20. My denominator becomes 36, a negative 5 times a negative 1 is a positive 5. And so, I forgot to put 25 here, sorry, that's 25. So it's a positive 25. A negative 5i times a positive 5i is a negative 25i squared. All right, so when I rewrite this, remember standard form, so I'm going to put the negative 20 first, so I get negative 20 plus 24i divided by, and then 36 plus 25 is 61. Now you want to write this in standard form, so you're going to rewrite this as in the form a plus bi. So negative 20 divided by 61 plus 24i divided by 61. So that goes here. So negative 20 divided by 61 plus 24i divided by 61. So that's number 3. Number 4. So number 4, you want to, so you're given that the endpoints, so these two are endpoints of the diameter of a circle, and you want to write this in standard form. So when you look at this in terms of what the graph looks like, and you didn't have to do this on the test, but basically what the graph looks like is this. So these are the endpoints of the diameter. So one of the endpoints is negative 7, 3. So negative 7, 3 is here. And then the other endpoint is 3, 7, which is here. And I'm going to draw this segment here. I'm doing this freehand, so it's not going to be perfect. So that's the diameter of the circle. Now if I draw the circle, and I'm doing the best I can here, but if I draw the circle, I get something that looks like this. Now it's not a very good circle, but we're going to use that for the idea of how to deal with this. So these are the diameters. Remember, this is one of the diameters. There's an infinite number of diameters. Now remember, the diameter goes through the center of the circle. So let's say this right here is the center of the circle. I'm estimating what the center is. And so there's an infinite number of diameters. So all these are diameters. There's an infinite number of those. Notice that all these diameters go through the center of the circle. But the only thing we know are the endpoints of this diameter. So this endpoint is 3, 7. This endpoint is -7, 3. And so if I want to write the equation of a circle in standard form, remember standard form is x minus h squared plus y minus k squared equals r squared, then I've got to know two things. I must know the center, hk, and I've got to know the length of the radius, which is r. So those are the two things I must know. So if you go back to the graph here, notice that the diameter goes to the center. And so one of the things we talked about previously was that if you're given a segment, then you can find the midpoint of that segment. So if you look at this, the diameter here, the midpoint of the diameter is the center. So if you want to find the center of the circle, then we've got to find first the midpoint of this diameter. So the midpoint of the diameter, and so here's your midpoint formula, is going to be the center. So that's going to be your center of the circle. And so the midpoint formula is where, remember, label these x1, y1. So let's call this the first point. So it'll be x sub 1, y sub 1. And the second point here will be x sub 2, y sub 2. So to find the midpoint, remember the formula is you add your x's together. So x1 plus x2 divided by, and you take half of it. And then do the same thing with the y coordinates, y1 plus y2, and divide by 2. And so you're just going to substitute. So the midpoint or the center of this particular circle then will be, and remember, we're talking about a point here, so make sure you use parentheses. So you add your x's together. It does not matter in the order in which you add your x's or the y's. So you can say -7 plus 3 divided by 2, comma, and then you add your y's, 3 plus 7 divided by 2. And so that becomes -7 plus 3 is a -4 divided by 2. And then 3 plus 7 is 10 divided by 2. And so the center of the circle is going to be, simplify this, so that'll be -2, comma, 5. So this right here happens, we're pretty close, we were pretty close here. So that happens -2, 5, so that happens to be the center of the circle. So I found h and I found k. Now the only other thing I got to find is the radius, the length of the radius. Well, remember, all we know is the length of the diameter. That's all we were given. Now there are a couple of ways you can find the length of the radius. Now that we know the center, you can find this distance, or you can just find the distance of the diameter and divide by 2. And that's the way we did it. So basically to find the length of the radius, remember the radius is half the diameter. So the radius is the diameter, the length of the diameter divided by 2. So to find the length of the diameter, just like we did with one of the previous problems, you use the distance formula. So the distance formula is the square root of x2 minus x1, so you subtract your x coordinates, you squared, and then you subtract your y coordinates and you square. And so the diameter then, the length of the diameter will equal the square root of, so we can subtract your x coordinates from each other. So we're going to say 3 subtract -7, -7 squared, plus, and then 7 subtract 3 squared. And so 3 subtract negative 7 is 3 plus 7, so that's 10 squared. 7 subtract 3 is 4 squared. So I get the square root of 10 squared is 100, and then 4 squared is 16, so it becomes the square root of 116. Now don't simplify that because at some point you're going to be squaring the radius, and so square root times itself is just that radicand. You don't have that square root any longer. So leave it like this for right now. Okay, so be a little bit careful. This is the radius that you got to substitute. That's not the radius here, that's the diameter. So you got to remember that the radius then is the length of the diameter divided by 2. So that's your radius. That's the length of the radius. Now do not make the mistake and simplify this to reduce. Don't say 2 will go into 116 because that's not 116. That's the square root of 116. So you cannot reduce like that. So this is an irrational number in the numerator. The denominator is a rational number. So you cannot, so there's two different kinds of numbers. Now if that was 116, just 116 up here, then you could reduce. So be careful there. Alright, so then we're going to substitute this into the formula. So the next step is to substitute into the formula. So you're going to get x subtract h is negative 2 squared, plus y subtract k is 5 squared, equals the radius, which is this, squared. So then we're going to rewrite this expression. So I get x subtract negative 2 is x plus 2 squared, plus y minus 5 squared, and then over here that becomes the square root of 116 divided by 2 times itself. And so when I do this, I get the square root of 116 times the square root of 116 is 116. 2 times 2 is 4. And so 116 divided by 4 happens to be 29. And so that is your answer. So that goes in this blank. So it'll be x plus 2 squared plus y minus 5 squared equals 29. Okay, number 5. This time in number 5, you're given the general form of the equation of a circle, and you want to write it in standard form. So remember, standard form again is x minus h squared plus y minus k squared equals r squared. And so when it's given in general form, you're going to have to use completing the square. So you got to use completing the square for that one. And so you're going to complete the square on the variable x's, and you're going to complete the square in the terms that have the variable y's. But to do that, you got to put the terms with the x's together and put the terms with the y's together and bring the constant term to the other side. So basically what's going to happen is you're going to have this. You're going to have x squared plus 6x, leave some space because you're going to be, when you complete the square, you're going to add a number to both sides. And then put the x's, you're going to say plus 6x, plus y squared minus 8y, and leave some space, and that's going to equal a negative 5, because remember you got to subtract 5 from both sides. So you got to leave all the variables on one side, all the variable terms on one side, and the constant on the other side. Now what's going to happen is now you're going to complete the square on the variable x's, on the terms that have the x's, and you're going to complete the square on the terms that have y's. So you're completing the square twice. And so in completing the square, you're going to add a number to both of these expressions, and so you're going to end up with a binomial squared. So that's the idea. So you can end up with a binomial squared. So to make it look like the equation, the standard form of the equation of a circle. So this is going to end up being a perfect square trinomial. So you want to write this as a perfect square trinomial. Okay, so to complete the square on the terms involving the variable x, and also remember you got to have x squared to be 1, y squared to be, the coefficient to be 1, I meant, and they are here. So you can take the coefficient of the x term, of the first degree term, which is 6. You can divide that by 2. Whatever that is, you're going to square it. So 6 divided by 2 is 3, and 3 squared is 9. So you're going to add 9 to both sides, just like this. Now what happened since you did that was this is now a perfect square trinomial, so you can factor it as a binomial times itself. So x squared plus 6x plus 9 happens to be x plus 3 squared. Because remember, positive 3, you can always check. Remember, if you fall this out, you get this back. So x times itself, remember that's being squared, is x squared. Let's go with the last now. A positive 3 times a positive 3 is a positive 9. And when you do the outer inner, the outer is going to be 3x, and here's going to be 3x, you get 6x. Over here, when I complete the square on the variable y's, I'm going to take the coefficient of y, which is negative 8, divide by 2. Whatever that's going to be, I'm going to square it. So negative 8 divided by 2 is negative 4. Negative 4 squared is a positive 16. So I'm going to add 16 to both sides. And so when I factor this, there should now be a perfect square trinomial. So I'm going to get y minus 4 squared. Because a negative 4 times a negative 4 is a positive 16. And when you FOIL it, you're going to get a negative 8y. So remember, this middle sign's negative, so that's why you see a negative here. Middle sign's positive, that's why you see a positive here. And then over here, you're going to add those three numbers together. Negative 5 plus 9 is 4. 4 plus 16 is 20. And so that's your answer. You're done. That goes here. So x plus 3 squared plus y minus 4 squared equals the radius squared. Okay? Remember, this is r squared, not r. So don't take the square root of 20 and put that here. That's not the square root of 20. You're finding r squared. So r is the square root of 20, but that's not what goes here. It's r squared that goes here, so that's 20. That's your answer. Okay, number 6. You want to solve this quadratic equation by factoring. And so it's already in standard or general form. So remember, bring all the terms to one side, 0 to the other. The GCF here is 1. So I'm going to go directly to the two binomials. And I'm going to use a zero factor property to do this. So when you solve by factoring, you're actually using a zero factor property. And so when I factor this, there are two possibilities with 6x squared, 3x times 2x, and then 6x times 1x. I'm going to use a 3x and a 2x. The last sign is 3, or the last term is 3. The last sign is positive. So since the last sign is positive, that means that both of these signs can be the same. It's going to be this middle sign. So I know they're both going to be negative here. And then for 3 cannot go here. Remember, if 3 went here, that means you could factor out a 3, which you couldn't do here. So 3 has to go here, the 1 has to go here. Now let's check. 3x times 2x is 6x squared. Let's go to the last. I'm checking by using FOIL. A negative 1 times a negative 3 is a positive 3, and the outer, if you look at this, is a negative 9x, and the inner is a negative 2x, and when I add them up, I get a negative 11x. Alright, so I factored this correctly. Now I'm going to use a zero factor property. So what that says, I'm going to set each factor equal to 0. You got to have 0 on this side. You can't have any other number but 0. So when I set each of these equal to 0, I get 3x minus 1 equals 0, and then 2x minus 3 equals 0. So I went from a quadratic equation to two linear equations. And so to solve this linear equation, I'm going to add 1 to both sides. I get 3x equal 1, and divide both sides by 3. I get x to be 1/3. So that's one of your solutions, 1/3. Over here, when I add 3 to both sides, I get 2x equals 3. Divide both sides by 2. Your other solution is 3/2. So those are your two solutions, 1/3 and 3/2. In number 7, you're asked to solve this quadratic equation by using a square root property. So remember, in using a square root property, you're going to use a square root property when you have something that looks like this. Some expression squared equal a number. Some expression squared equal a number. And that expression squared has to have that coefficient in front of it being a 1. And if you look at this, this is in this form. And so what we're going to do, I'm going to go ahead and rewrite this out. What we're going to do now is we're going to take the square root of both sides. And remember, you take the square root of both sides, you get that plus or minus. So So there's going to be a plus square root of negative 16 and a negative square root of negative 16. And so the square and the square root undo each other. So you get 2x minus 1 equals plus or minus the square root of negative 16, remember, is the square root of a negative 1 times the square root of 16. The square root of a negative 1, remember, is I, and the square root of 16 is 4, so that becomes 4i. So this is plus or minus 4i. Since I am dealing with an imaginary number here, I'm going to go ahead and write it in compact form. So basically all I'm going to do is I'm going to add 1 to both sides. So I'm trying to get x by itself, combine like terms. I get 2x, a negative 1 and a positive 1, 0, equal, and then this on this side, that's 1 plus or minus 4i. And then I'm going to divide both sides by 2 to get x by itself. So when I rewrite this over and divide by 2, divide both sides by 2, I get x to be 1 plus or minus 4i divided by 2. So that goes here. Now, there are multiple ways, so that's one of your solutions. Those are your solutions. So there are two solutions, 1 plus 4i, or you can write it as 1 plus 4i divided by 2, and the other one is 1 minus 4i divided by 2. So those are multiple ways to write your solutions. You could have also written it in the form a plus bi. So in other words, you could have said 1/2 plus or minus 4i divided by 2. You could have reduced the 4 into 2 here, so you could have said 1/2 plus or minus 2i. You could have rewritten it like this, where you said 1/2 plus, and then 4 divided by 2 is 2i, and then 1/2 minus 2i. So those are all different ways of writing the answer. This right here is in that compact form, these right here, and then here I just separated them. But don't make a mistake, this is a mistake, and do this. Don't say 2 divided by 2 is 1, 2 divided into 4 is 2, and say the answer is 1 plus or minus 2i. That's not true. Because if you think about this, see this, both terms up here are being divided by 2. So when you did this, all you've done was divided 2 into that second term and forgotten about that first term. So notice, this is supposed to be 1/2, and look what you have. You just have a 1. So don't do the mistake. When you reduce like this, it's got that 2 down here has to be divisible into both terms before you can reduce. So that's why it's a good idea, if you want to reduce the 4 into 2, to write it like this. See how I wrote it as 1/2 plus or minus 4i divided by 2? Then I reduced the 4 into 2 here and I got that 2i. So now it's supposed to be 1/2, not 1. Okay, number 8. You want to solve this quadratic equation using a quadratic formula. So if I'm going to use a quadratic formula, I've got to first of all put this in general form or standard form. So in other words, I need 0 on this side. So I've got to rewrite this as 2x squared minus 3x plus 4 equals 0. So remember, you're going to add 4 to both sides. Now the quadratic formula is this. It's the opposite of b plus or minus the square root of b squared minus 4ac. All that's being divided by 2a. So I've got to substitute the values of a, b, and c back into this. So remember, a here is 2, the coefficient of x squared. B is the coefficient of x. So that's negative 3, not 3. Negative 3 is b. And c is your constant, which is a positive 4. So when I substitute those values into the formula, I get this. I get x equal, that's your variable. So this says the opposite of b. So b is a negative 3. The opposite of a negative 3 is a positive 3. Plus or minus the square root of b squared. So put that in parentheses. So negative 3 squared. If you don't put in parentheses, so if you didn't put that in parentheses, that would be a negative 9. But remember, b squared is always going to be positive or 0, never negative. Minus 4 times a is 2, times c, which is 4. All that's being divided by 2 times a, and a is 2. So I get 3 plus or minus the square root of, now let's simplify the radicand, which is a discriminant. A negative 3 times itself is 9. A negative 4 times 2 is a negative 8. A negative 8 times 4 is a negative 32. All that's being divided by 4. And so 9 subtract 32 is going to be a negative 23. So I get 3 plus or minus the square root of a negative 23. All that's being divided by 4. But remember, you need to simplify the square root of negative 23. You have to use the fact that the square root of a negative number is I. So remember, the square root of negative 23 means the square root of a negative 1 times the square root of 23. Now, I cannot simplify the square root of 23 because 23 is prime. But I can rewrite square root of negative 1 as I. So this can become 3 plus or minus I square root of 23 over 4. So since I am dealing with imaginary solutions, we can write it as a plus or minus form. So we'll just say 3 plus or minus I square root of 23 over 4. So you get two solutions. Now you can also write it as two separate solutions by saying this: 3 plus I square root of 23 divided by 4, comma, 3 minus I square root of 23 divided by 4. You could have also, if you wanted to, see I have the I written in front, you could have put it in the back as long as it doesn't look like it's under the square root. So you got to be careful. So you would say 3 plus or minus the square root of 23. I knows I have the I on the outside. All that's being divided by 4. So those are all different ways, and there's some other ways you can write this, but these are the more common ways you're going to write it. Okay, now number 9, quadratic formula again. So this is already in standard / general form. So let's determine what A, B, and C are. So A is 3, B is 2, and C is negative 3. So remember, A is the coefficient of x squared, B is the coefficient of x, and C is your constant. So when I plug it back into the formula, I get x equal the opposite of B. So B is 2, the opposite of 2 is a negative 2, plus or minus the square root of B squared, so that's 2 squared, notice the parentheses, minus 4 times A is 3, times C, which is negative 3. All that is being divided by 2 times A, so 2 times 3. So I get negative 2 plus or minus the square root of B squared, so 2 squared is 4. A negative 4 times 3 is a negative 12. A negative 12 times a negative 3 is a positive 36. All that's being divided by 6. 2 times 3 is 6. When I simplify the radicand, that becomes negative 2 plus or minus the square root of 40 divided by 6. Now, you want to simplify this as we did in class. So the square root of 40, the largest perfect square that goes into 40 is 4. So remember, the square root of 40 is the square root of 4 times 10. So the square root of 4 to the square root of 10, so that's 2 square root of 10. So that goes here. So I get negative 2 plus or minus 2 square root of 10 divided by 6. Now don't leave your answer like this because you'll notice that these, I'm circling these, so these three terms here that I'm circling are all divisible by 2. So let's go ahead and do that. So I'm going to go ahead and rewrite this. So I'm going to simplify 2 into all of those. So 2 into 6 is 3, 2 into negative 2 is a negative 1, and then 2 into 2 here is 1. So I end up getting negative 1 plus or minus the square root of 10 divided by 3. All right. Now, you could have also gotten this by just doing this. So you could have said this. You could have said negative 2, 6 plus or minus 2 square root of 10 over 6, and then reduce each one. So negative 2, 6 is negative 1/3, plus or minus, and then reduce that. That's going to be the square root of 10 divided by 3, which is what this is. So you could have written it as negative 1/3 plus or minus the square root of 10 divided by 3. You could also written this as two separate solutions, like negative 1 plus the square root of 10 divided by 3, or plus or minus. Oops, sorry, I did say two separate solutions. So plus 10 divided by 3, and the other will be negative 1 minus the square root of 10 divided by 3. So these are all different ways of writing the solution. Number 10, you want to solve this absolute value equation. Now, this is not a linear equation, that's an absolute value equation. So when solving an absolute value equation, you need to remember the basic one that we looked at. The basic one was this. The absolute value of x equal 2. So remember that there are two solutions, x equal 2 and x equal negative 2. Because the absolute value of x, the absolute value of 2 is 2 and the absolute value of negative 2 is 2. So when doing this, you got to remember when you have an absolute value equation, you're going to rewrite this as two separate equations. Now, when you rewrite this as two separate equations, your absolute value expression has to be by itself, and that has to be a coefficient of 1 in front of it, and it is. So since the absolute value expression is already by itself, that's where you separate these into two equations without the absolute value bars. Notice I rewrote this as two equations without the absolute value bar. So you have to say 3x minus 2 equals 7, or, and the other equation is this, 3x minus 2 equals a negative 7, okay? So you rewrite, so with the absolute value equation, you're going to get two separate equations without the absolute value bars. So notice I went from an absolute value equation to two linear equations. So we solve each one, so I'm going to add 2 to both sides here. Combine like terms, I get 3x equal 9. And then if I divide both sides by 3, I get x to equal 3. So that's one of my solutions, is 3. And you can check real quick, just say, go back to your original equation. 3 times 3 is 9. 9 minus 2 is 7, and the absolute value of 7 is 7. Okay, over here, I'm going to add 2 to both sides and combine like terms. I get 3x equal a negative 5. And if I divide both sides by 3, I get x to be a negative 5/3. So that's your other solution. And you can check it. 3 times a negative 5/3. 3 times a negative 5/3 is a negative 5. So 3 times a negative 5/3 is a negative 5. Negative 5 and a negative 2 is a negative 7. And the absolute value of a negative 7 is 7. Okay, number 11, you're solving this linear equation. Remember, this was an absolute value. This was not linear. So you rewrote this absolute value equation as two equations without the absolute value bars. And these turned out to be linear right here. And number 11, when solving this linear equation, you can distribute the 4. Don't say 3 plus 4 is 7, distribute the 7, because remember, you got to follow the order of operations. So the order of operation, you do multiplication before you add. So every term in here is going to be multiplied by 4. So I get 3 plus 4 times x is 4x. 4 times a negative 2 is a negative 8. Plus x equals 2x minus 5. Combine like terms, 4x plus x is 5x. 3 and a negative 8 is a negative 5 equals 2x minus 5. Bring all the variables to one side, constant to the other. I'm going to subtract 2x from both sides, and then combine like terms. 5x minus 2x is 3x, minus 5 equal, and then that's going to be negative 5. Adding 5 to both sides, I get, combine like terms, I get 3x equal, and then that's 0. Getting x by itself, I'm going to divide both sides by 3. And to get x to be 0 divided by 3 is 0. That's a solution. So this is a solution to this equation. X equals 0. That's your solution. So don't say it's no solution. It's 0. 0 is a solution because you can check. 0 subtract 2 is a negative 2. So let's check this. Go back to the original. So 3 plus 4 times x minus 2 plus x equal 2x minus 5. So I'm going to go ahead and substitute 0 into here. So 3 plus 4 times 0 minus 2 plus 0, remember x is 0, and I want to see if that's going to equal 2 times 0 minus 5. Well, order of operations on this side, 0 subtract 2 is a negative 2, so it becomes 3 plus 4 times a negative 2 plus 0, so that's just this. 4 times 2 is a negative 8, so I get 3 plus a negative 8, and then 3 plus a negative 8 is a negative 5. So I get negative 5 on this side. Over here, 2 times 0 is 0, and 0 subtract 5 is a negative 5. So negative 5 equals negative 5, so 0 is a solution. All right, number 12, you have this rational equation, but notice that your denominators are just whole numbers. They're just integers. There are no variables down here. So you just find the LCD, so you want to clear the fractions. So you can clear the fractions by multiplying both sides by the LCD. And so you look at your denominators, you have 2, 3, and 6. So your LCD is going to be 6. That's the smallest number that 2, 3, and 6 go into. You could use a common factor, a common denominator, but the least is 6. So you could have multiplied both sides by 12. You could have multiplied both sides by 24, and so on. But it's easier to use the smallest. Okay, so I'm going to rewrite this side. Since these are two fractions on the left side, I'm going to put that in parentheses. So I'm going to say x minus 3 divided by 2 minus, and then x plus 5 divided by 3. This side, notice in parentheses, has to be multiplied by 6. Over here, since that's just one fraction, I'm just going to leave it as 5/6 without parentheses. Now the next step is to get rid of the parentheses. Don't make the mistake and reduce first. Don't say 2 into 2 is 1, 2 into 6 is 3, and distribute the 3, because that's not correct. Because this has to be multiplied by 6, and this has to be multiplied by 6. So if you reduced first, you would have multiplied this by 3, and that's incorrect. That's supposed to be 6. So be careful. So you can distribute next. So you're going to say 6 times in parentheses x minus 3, the numerator, I'm going to put that in parentheses, divided by 2, minus, and then 6 times in parentheses x plus 5, divided by 3, equal, and then 6 times 5, 6. Now I'm going to reduce. Reduce after you distribute. 2 into 2 is 1, 2 into 6 is 3, so this becomes 3 times x minus 3, 3 times x minus 3. 3 into 3 is 1, 3 into this 6 right here is 2, so it becomes a negative 2 times x plus 5. Equal, and then these 6's divide out, so you're left with 5. So that's what I have. So notice I clear the fractions. I no longer have denominators with something other than 1. Now I'm going to distribute the 3. I'm going to distribute the negative 2. So 3 times x is 3x. 3 times a negative 3 is a negative 9. A negative 2 times x is a negative 2x. And a negative 2 times 5 is a negative 10, equal 5. Combine like terms, 3x minus 2x is x. A negative 9 and a negative 10 is a negative 19, equal 5. And then adding 19 to both sides and combining like terms, I get x to be 24. So that's your solution, 24. Okay, number 13. Number 13, you have this rational equation with variables in the denominator. And so notice that these are polynomials. So this polynomial, x plus 3, you cannot factor. Some of you need to factor your denominators. X minus 6 is already prime. You cannot factor that. But here I can factor this. And when you factor this, it's going to turn out that it's going to be these two binomials right here. So when you factor the x squared minus 3x minus 18, I get x plus 3 times x minus 6. So that's how you factor this denominator. Now, just like we did in the previous problem, you're going to clear the denominators. You're going to clear your fractions by multiplying both sides by the LCD. But before we do that, let's find the restrictions. So you got to find restrictions here. Now, in the previous problem, you didn't find restrictions because your denominator is never 0. This denominator is 2, this denominator is 3, this denominator is 6. It's never going to be 0. Here, though, this can be 0. This denominator can be 0. Remember, you cannot divide by 0. So this is 0 when x is negative 3. So one of your restrictions that x cannot equal negative 3. So basically, you take each of your factors and you're going to set it equals 0. So you're going to say x plus 3 equals 0 and then solve for x. So you're trying to find out where's this 0. So this is 0 when x is negative 3. So that means that x cannot equal negative 3. Over here, you got to find out, well, where is this x minus 6 equals 0? Well, x minus 6 equals 0 when x is 6. Over here, your factor here is x plus 3, but we already took care of it, and then the same thing here. So you have two restrictions here, negative 3 and 6. Now you got to find your LCD. So your LCD, remember, has to include every factor that you see. So this factor here is x plus 3, I've got to use it. This factor here is x minus 6, I have to use it. This factor x plus 3, I already have it, and then this x minus 6, I already have it. So your LCD is x plus 3 times x minus 6. The next step is to take your LCD and multiply both sides by it, just like you did in this previous problem. So when your LCD here is 6, and so you multiply both sides by 6. Except here, you're going to be multiplying both sides by a variable expression. So since I had two fractions on this side, I'm going to put that in parentheses. So 5 divided by x plus 3 minus 3 divided by x minus 6 equal, leave some space here, and this is going to be negative 25. And rewrite this part with these two factors here. So x plus 3 times x minus 6. I'm going to multiply both sides by this LCD. So x plus 3, x minus 6 times this left side equal, and then x plus 3 times x minus 6 equals the right side, times the right side. Now I'm going to distribute, just like you did in the previous problem. You distribute first and then reduce. So distribute first and then reduce. So this becomes x plus 3, the LCD. Remember, this is your LCD right here. So your LCD times that first fraction minus the LCD times the second fraction. Okay? Equal, and I'm going to just go ahead and reduce this. So these divide out, and you're left with negative 25. Okay, now let's reduce what we can here. So the x plus 3's divide out, and you're left with 5 times x plus 6. Minus these x minus 6's divide out, and you're left with 3 times x plus 3 equal negative 25. All right, so just like the previous problem, we had this, the next step is to distribute. So I'm going to distribute here, and so I get 5x plus 30, 5 times 6 is 30. Then distribute the negative 3, I get negative 3x minus 9 equal negative 25. Combining like terms, 5x and a negative 3x is a 2x. 30 subtract 9 is a positive 21 equal a negative 25. Subtracting 21 from both sides, I get 2x equal, this is 0, negative 46. And then divide both sides by 2, I get x to be a negative 23. So let's just make sure I didn't make a mistake here. Oops, right here I made a mistake. X minus 6, I put x plus 6, that's x minus 6. Be careful. So it's going to be minus, so that means I'm going to add 21 to both sides. Alright, so 2x minus 21, oops, sorry, a negative 30 and negative 9 is a negative 39. So I'm going to add 39 to both sides. Add 39 to both sides, and so a negative 25 and a positive 39 is a positive 14. So a positive 14 divided by 2, so that's going to be a positive 7. All right, so notice you got to be careful because you could easily make the mistake where you instead of saying x minus 6, you write as plus 6. So be careful. And so I get the solution is 7. Now remember, once you get this proposed solution, you got to make sure it's not your restriction. So if this was a 6, that is a restriction, which means I could not divide by 0, so you would say no solution. If I had ended up with, let's say, -3, the same thing. -3 is a restriction, you would say no solution. But 7 is not a restriction, so 7 is going to be my solution. All right, 14. Here you're solving an inequality. Now this is a linear inequality. And you're asked to graph the solution set and state the solution interval notation. So just like you did with an equation, you distribute first. So I get 2x minus 8 plus x plus 1 is greater than 5x plus 3. And so combine like terms, 2x and x is 3x, a negative 8 and a positive 1 is a negative 7 is greater than 5x plus 3. I'm bringing all the variables to one side, constant the other, so I'm subtract 5x on both sides. And so 3x minus 5x is a negative 2x minus 7 is greater than, and that is 3. Adding 7 to both sides, I get, and combine like terms, I get negative 2x is greater than 10. Now, to get x by itself, I'm going to have to divide both sides by -2. But remember, when you divide or multiply an inequality, both sides of an inequality by a negative number, which I am here, you've got to reverse this inequality symbol. So negative 2x divided by negative 2 divided by negative 2 is 1. 1 times x is x, so x is less than -5. So negative 5 is here. Since there's no equal sign, I have to use parentheses, and I need to graph all the solutions, so all the real numbers that are to the left of it. So all my solutions are less than -5. So in interval notation, you would say negative infinity to -5 parentheses. All right, now just some of you would probably, right here, some of you would probably do this. So let me just show you what someone else could have done. So 3x minus, I'm just going to rewrite this over. Just to remind you what else you could have done. So you see how I brought the variables to the left side? You could have brought the variables to the right side. Does not matter. So I could say subtract 3x, and so I get -7 is greater than 2x plus 3. Then subtract 3 from both sides. I get -10 is greater than 2x. So -10 is greater than 2x. So then we divide both sides by 2, and so I get -5 is greater than x. But remember, it's always a good idea to rewrite it so the variable is on the left side. So this becomes x is less than -5, and that's what this is. All right. Now, number 15, just like we did in the previous problem, in number, let's see, it was number 12. When you go back to number 12, is very similar to number 15, except number 12 was an equation. In number 15 is an inequality. So you want to clear the fractions, so you got to find your LCD. So the LCD in number 15 is 6. So the LCD is 6. So you can multiply both sides by 6. Now the left side has 3 fractions, so x over 3, a -1/2, and a positive 2x over 1. So I'm going to put that in parentheses. So x divided by 3 minus 1/2 plus 2x less than or equal to, and leave some space here. So all I've done was rewrite the inequality, but I put the left side in parentheses. Now I'm going to multiply both sides by 6. So times 6 times 6. Now don't reduce. Don't say 3 into 3 is 1, 3 into 6 is 2, and distribute the 2. That's incorrect. You've got to distribute first and then reduce. So this is 6 times x over 3 minus 6 times 1/2 plus 6 times 2x is less than or equal to, and then let's go ahead and reduce this. That's 2, that's 3, so you get 9x. So this, when reduced, is 3 into 3 is 1, 3 into 6 is 2, so it becomes 2x. 2 into 2 is 1, 2 into 6 is 3, minus 3, plus 12x is less than or equal to 9x. Combine like terms, 2x plus 12x is 14x. Minus 3 is less than or equal to 9x. So I'm going to go ahead and bring the variables one side, constant the other. So I'm going to subtract 9x from both sides, just like this. And I get 5x minus 3 is less than or equal to 0. 9x minus 9x is 0. adding 3 to both sides, combine like terms, I get 5x is less than or equal to 3. And so when I divide both sides by 5, I get x is less than or equal to 3/5. Now all I want you to do here was just to write this in interval notation, so all your solutions are going to be less than or equal to 3/5. So you're going to say negative infinity to 3/5 with a bracket because 3/5 is a solution because of the equal sign. Okay, number 16, you have this compound inequality. Now remember what that reads as. So remember that says that 2x minus 1 is less than or equal to 6, and at the same time, notice the word I said and, at the same time it has to be bigger than negative 3. So in solving this compound inequality, it looks like this. We're trying to get the variable x in the middle. So what we're going to do is we're going to add 1 to all 3 parts, because right now I'm subtracting 1. And so negative 3 plus 1 is a negative 2 is less than, and they combine like terms, negative 1 and positive 1 is 0. So that's what you want to do. You want to get rid of this negative 1. And then that's less than or equal to 7. And then finally, we're going to divide both sides by 2. And so I get negative 1. Negative 2 divided by 2 is negative 1. It's less than x is less than or equal to 7/2. So you found the solutions. So the solutions to the original inequality, this compound inequality, it will be any number between negative 1 and 7/2, including 7/2 because of the equal sign. So here's negative 1. I'm going to need parentheses on negative 1. And then 7/2, remember, is 3.5. So 3.5 is here. I'm going to need a bracket here. And then shade in all the numbers between them. And then your interval notation, you're going to say parentheses negative 1, comma, 7/2 with the bracket. Okay, 17 is an absolute value inequality, but it's a greater than. So there is no way you can write it like this. Don't make a mistake and write an absolute value greater than as a compound statement that looks like this. Remember, this says greater. So think of the word or, greater, or. So it's got to be written as an or statement. So you got to separate that though into two inequalities without the absolute value bars, just like we did the equation earlier. Right here, we rewrote the absolute value equation as two equations without an absolute value bar. Same thing here with the greater than. You rewrite it without the absolute value bar, but you got to remember this. 3x minus 2 has to be bigger than 4, or 3x minus 2, and that's where you reverse the inequality symbol to take the opposite of the other side. It has to be less than negative 4. So when we first talked about absolute value inequalities, we did this example here. And so when think about this example, my solution would be any number that's greater than 2. So any number greater than 2 is the solution. Or we saw, and we also saw, or the solutions could be less than a negative 2. And so that's why when you rewrite in two separate ones, we rewrote it without the absolute value bar. So you see x is greater than 2 without it. Same thing here. The absolute value of 3x minus 2 greater than 4 becomes 3x minus 2 is greater than 4. But remember, there's another one though. So if all you have is this, you're just getting one part of your solution. So the whole process is incorrect. So to solve this inequality, you got to have two separate inequalities with an or statement. But the other side has to be this. So basically, you're going to reverse the inequality symbol and take the opposite of the other side. Just like when we did, it's the same idea as dividing by a negative number. So when I divided by, I can find it. So here, when I divided both sides by a negative number, I reversed. So the greater than become less than, and then here I got a negative 5. So the same thing here. So I'm dividing by negative 1. So basically, this greater than becomes less than, and this 2 becomes negative 1. Okay. So then notice you went from an absolute value greater than to two linear inequalities. So solve each one. So I add 2 to both sides. Combine like terms to get 3x is greater than 6. And then I'm going to divide both sides by 3. And so I get x is greater than 2. So I found one part of my solution, so which is this. All right, but remember, that's not, if all you have is this, that's not the correct procedure because you forgot about this other part. So you're going to add 2 to both sides and combine like terms to get 3x is less than negative 2. Divide both sides by 3, I get x to be less than negative 2/3. And so negative 2/3 is between 0 and 1, but closer to negative 1. And then so I'm going to have parentheses somewhere around here, and then going this side. All right, so that's your graph. And then your interval notation is say negative infinity, parentheses, negative infinity to negative 2/3, with parentheses, union, and then 2 to infinity. Okay, so that was the key to test 1.